Hi everyone, this is an introductory session for finite element analysis method, or called FEA. By the end of this session, you will be able to identify what is finite element, areas used in, concepts of finite element, and you will be doing two analyses, two gears, and gear and pulley on Ansys simulation using finite element method. First of all, what is FEA? It is a numerical method used to analyze complex geometry by dividing the problem into elements and nodes to solve the problem required. Most of engineering geometries are complex, and finding the exact solution is nearly impossible. So, other techniques like finite element analysis or CFD is using to find an approximate solution for your problem. Now, what areas we use FEA in? We use it in structural analysis. We also use it in solid mechanics, some thermal geometry, some thermal analysis problem, and we use only in vibration or modal analysis. So, now we should deal with some concept of any simulation or any technique using finite element method or CFD. The first concept is called discretization. A discretization method. It is dividing the complex shape into segments, small segments, and each segment contain nodes. You should choose a mathematical model, suitable mathematical model for your problem. After choosing your problem, a system of linear equation is found, and you need to be solved, and we will know this in the next slide. The second concept is called solid element. After dividing the small geometry into small elements, this element is called the discretized single element or simply solid element. For the third concept, it's called a boundary. What's a boundary? It is the outer physical condition that affects the elemental part. It can be force, moment, prescribed displacement, heat, temperature, heat flux, or whatever. To know better about boundary condition, you can see this rod is first, we divided it into segments or nodes. The node on the left, the red point, has a boundary called fixed support, no force or moving displacement on it. The last node or right node to your the right node in red, it has a force that pointing negative in y direction. For now, this concept can make you solve any problem by defining it in simulation. After choosing or applying boundary condition, then choosing your mathematical model, a system of equation will appear. You should model your system of equation into matrix to try to solve it. But in this course or in this topic, we will not dive into the techniques used to solve these equations. We will just know our equations, our boundary conditions, then our simulation package software like Ansys will deal with these linear equations. Remember that all this solution is not exact solution. It just give you an approximate solution to ensure your analysis. Now we have a general approach or procedure for any simulation. First step, you should build your physical model using any software, SolidWorks or Inventor. Second step, you should implement your model into the workbench or Ansys simulation. So, first step in pre-processing, we will be doing meshing, then assigning material, the favorable material you want to be solved, then apply defined boundaries. After this step, we will go to processing, choosing any or favorable mathematical model or mechanical model you want to solve, like mechanical, fluent, model, vibrational, or whatever. Last step, post-processing or showing your results from your simulation. Now Let's jump into your first simulation. We will open your software and the software step by step. Now we will model our two gears and making simulation analysis on it. First, you should draw your geometry on SolidWorks or Inventor. Then you should implement this model into Ansys. For older versions, you should save this assembly or this drawing into extension called IGS extension. In updated versions above 22, you can implement SolidWorks assembly directly into Ansys. For this step, you should save it, and now we'll go to Ansys to implement this model. After opening Workbench or Ansys simulation, you can see here the interface. From the toolbox, choose static structure, drag and drop here in the project schematic area. Now we will import our geometry. Right click on geometry, import geometry, then gear train solid part or IGS. After importing our geometry, we will open our model, mechanical or structure model, right click or edit or double click on model. After opening our mechanical model, you can see on your left there is geometry, material, our two geometry, gear 1, gear 2. To assign material, you can see gear 1, it's structure steel, gear 2, same material. If you want to add material, you can insert another material you want. But now we will go to mesh. But first we want to see the contact point here. You can see connection, contacts, contact region is between these two teeth of the gear. Let's undo this. Now let's focus our mission on mesh. Good analysis and good simulation is depending on good mesh. Good mesh has some parameters to be considered, such as number of nodes or number of elements. But first we want to know this user interface. The most important thing is units. You can change from here, unit system, metric. We want to be metric, millimeter, kilogram, Newton, and so on. Okay. Very good. Now generate mesh. By default settings, you will see it will produce a total number of element to be 1197. If you want to increase this number, we can simply change the element size. Let's say to be 5. Let's 10 milli. Then right click, update or generate mesh. You will see the total number of elements is increased. Let's say to be 10, to be 5 milli. Generate mesh. As you see, refining element is better simulation. Another parameter you can change for better simulation is called element order. Let it be quadratic. You can also change the size, his pen angle to be fine, not coarse, and so on. For now, or for this lab task simulation, all I want from you is to change only the element size to be the same 6696. Now I want to add boundaries for this gear. You can figure that this gear there is here in this whole shaft, and there is in the other gear another shaft to be supported here. So I want to make a support structure on that face and that face, but not fixed, just frictionless. Right click on static structure, insert. We can insert here fixed support, displacement, remote displacement. First I want to add remote displacement. Remote displacement on that surface and hold the control and that surface. What I want for initial conditions, I don't want to be any displacements in X component. As you can see here on X, no displacement in X, no displacement in Y, and no displacement in Z. So for rotation about X, no rotation about X, and no rotation about Y. The only allowable rotation is about Z. As you can see, this gear will rotate here in clockwise direction or counterclockwise direction. So I'm allowing only rotation about Z. Very good. Now right click on static structure, insert a frictionless support on that surface and that surface, hold apply. For the motive force or moment that will rotate that gear, you can see from this view I will apply a moment about this gear to rotate the bigger one. You can simply do the opposite, is the same. To apply some moment, right click on set structure, insert. Here is pressure, hydrostatic pressure, force, remote force, bearing load. I want a moment. I will select that face and then apply. The magnitude of the moment, let's say to be 5000 Newton per meter. As you can see, it is always in the counter clockwise, the positive direction. If you want to change the direction, you can simply press negative. You can see it's reversed, or you can change the direction from down there. Very good. Now everything is done. Our meshing is complete. Our boundaries and bounds force are implemented. Now I want to make or start our calculation model. Simply from this solution, what I want to add, I want to see the total deformation. I want to see the equivalent stress. I want to see stress tool to evaluate maximum factor of safety. Now right click on solution and solve. As you can see here, the bar for overall progress. We will wait until the calculation is done. Now the solution is done. You can see the total deformation from here. Simply press left click on it. You can see that the maximum deformation and the minimum deformation is 0.001 milli. As you can see the unit here, and the maximum is 0.01 on the applied moment face, and the minimum is less than 0.002 milli. It's okay. This small deformation is due to the small moment we applied. You can change any value you want, and you can see the deformation from that moment. The equivalent stress also, you can see the equivalent stress is in the connecting gears or contact faces. From here you can find the maximum and minimum points. The minimum you can see is here, the blue one. The maximum is on that face. What is the value of the maximum? Is 4.88 megapascal, also due to the low moment we applied. For the equivalent stress tool, we will see that the factor of safety we have is 15. To make these two gears move, to make some simulations, you can apply the graph icon here. You can see from the movement of the moment counterclockwise, the total stress and deformation is applied here. Also, equivalent stress, let's see from the point. You can make the video faster or slower by reducing the time frame. 2 seconds acceptable. Now, to import this video, to export this video, you can simply press export from here. Very well. Your first simulation with gears is done. Now we will move to your second Ansys simulation. We will follow the same steps but different configuration geometry. The second simulation we will have a shaft and a gear on it and a pulley. This will help you with your project in gearbox simulation. We will do the same steps, import our geometry and follow meshing, then adding material, and finally finding out our solution. Drag and drop static structure. Right click on geometry, import. We will import shaft with gear and pulley. Now geometry is done. Open mechanical model. Mechanical model is opened. You can see same geometry, 3 parts, pulley, gear and shaft, structure steel, structure steel, structure steel. We will do generate mesh with the default of our software. We have 19,645 element. You can change element size as you wish. For our static structure, we will add the boundary condition. Right click here, select remote displacement, this face, hold control, and that face. Apply. What we want, this shaft has no displacement in X or Y or Z. Clear. For rotation about X, it will rotate about X axis, but no rotation about Y or Z. So rotation about Y and rotation about Z is 0. Now we applied remote displacement. Second step, we will add a fixed support on that face of the gear. Why of that? Because from the previous simulation, you know that gear is interconnected with the next gear to it, so it will act as a fixed support on that face to be in the middle. And press apply. For the last boundary condition, I want this pulley will rotate about X axis, so I will add a moment. You can add it from here or right click and insert moment. Choose that face, press apply. Let's say also 500 Newton dot millimeter. The direction will be in x-axis, or you can select the direction of the moment by changing define by vector to be component. What we want a direction in the x direction, so this will be 500 Newton dot millimeter. Change, select this face, applying. You can see it will rotate this direction. If you want to reverse it, just press negative and will be changed. Very good. Same steps will add total deformation to show in our solution, total stress, and factor of safety to be considered in our calculations. Right click, then solve, or hold solve from here. I will pause until the solution is done. Solution is completed. For the total deformation, you can see here the motion of that shaft, moment or torsion, this fixed gear. Total deformation will be 0.03 milli, it's acceptable. Equivalent stress, the maximum will be 53 megapascal and minimum less than 0. Let's see the position for maximum or minimum stress. This is minimum down there, maximum in the fixed support. As you can see, there is a bending due to fixation from this point. Let's see safety factor. Minimum will be 4, maximum will be 15. The minimum is here, the maximum will be here. So this simulation is done. You can increase your number of elements for finer meshing and better simulation. This is for now your introductory session for finite element analysis. All the geometry will be attached in model. You can apply yourself and practice before your project. Thank you. See you next time. Bye.